Last class we discussed what's a best case, worst case, and average case running time of an algorithm mean. So what's the best case running time of an algorithm? So that is given input size, say n. So what is the minimum number of operations performed in that algorithm for any input of size n? That denotes the best case running time. What does this worst case running time denote? Given input size, say n, what is the maximum number of times that a basic operation is performed, or maximum number of operations performed in that algorithm for any input of size n? What does this average case running time denote? On average, any input of size n is given, how many times that a basic operation is performed, or what is the total number of operations performed in that algorithm on average. Okay. But in average case, we need to know what is the distribution of input. And linear search algorithm, we discuss what's the best, worst, and average case running times. So what is the average case running time of linear search? What is the average case running time of linear search? What is its order of growth? What is the order of growth of linear search algorithm in the average case? Order of growth of linear search algorithm in the average case. On average, how many number of comparisons are performed? Under the assumption that all inputs are equally likely, we showed that on average n plus 1/2 number of comparisons are performed. That means what is its order of growth? What is its order of growth? Its order of growth is n. So what is t average of n then? Average case running time of linear search. It can be written as theta of n. Is that correct? Average case running time of linear search is theta of n. Similarly, average case running time of linear search, can we write it as big omega of n? Average case running time of linear search, can we write it as big omega of n? Yes. Why? Because order of growth is n. We know that order of growth is n. N is big omega of n is true. Hence, this is also correct. Can we write it as like this? Average case running time of linear search is big O of n. Yes, this is also true. Why? Because order of growth is n. N is big O of n. This holds. Hence, this is also true. This is also true. Just a second. T average of n is big O of n. That is also true. That is also true. Now, this average case running time we calculated under what assumptions? What are the assumptions that we considered here in order to calculate average case running time? What are the assumptions about the input? So, two assumptions we consider now. One is the input, no, it is simple uniform distribution. Simple uniform distribution. What is that we assumed here? That is, each position is equally likely. Each position is equally likely. There are n positions per key. Whatever be the probability that it is present in first position, same thing is the probability that it is present in second position, and so on. The same thing is the probability that it is present in nth position. Each position is equally likely. So this is one assumption. What is the other assumption that we have made? Search is always successful. Search is always successful. That means no unsuccessful case occurs. We always assume that always key is present in the given list of n elements. given list of n elements. Whether can this search is successful be true always? Can the search is successful be true always? No guarantee, no. So search may be successful or may not be successful. Hence, search is successful means what is success probability? Search is always successful means what is success probability? Search is always successful. That means what is the probability of success? What is the probability that key is present in the given list? Search is successful. Okay, so whenever you write exam, you always clear that exam. Okay, whenever you attempt to get, it is understood that you clear it. You get good rank in that. Now, what is the probability of your success in the GATE exam? Your success in GATE exam? What is probability of success? Your success in GATE exam? See, whenever a student, specific student, whenever he or she writes GATE exam, it is understood that automatically they qualify and get good rank. That guarantee is given. Now you tell me what is the success probability that the candidate qualifies in GATE? What is the probability that the candidate qualifies in GATE? Whenever they write, they qualify. Then tell me what is the probability of qualifying in the GATE?
100%.
100%. 100% means probability is always between 0 and 1, no? Then what is the probability? 100% means what is the corresponding probability?
1.
That means success probability is 1. That means always search is successful. But there is always, it need not be the case, no. Sometimes search may be unsuccessful also. That means actually, okay, no, actually success probability may not be 1. It is actually success probability is actually it is between 0 and 1. It can be anything between 0 and 1, no? Success probability is anything between 0 and 1. Now we calculate what is the average number of operations performed when success probability is, say, P. When success probability is P, where P is success probability. That's what we calculate in linear search. Earlier, we calculated average case running time with assumption that search is always successful with the probability 1. Now we are going to calculate in general. That means we assume that it follows a simple uniform distribution, but success probability is P, where P varies from 0 to 1. It can be any value from 0 to 1. Okay. Now here also let X be a random variable denoting number of comparisons made. What is the value of X? What is the value of X? Linear search, we are searching for a key. It has n elements. What are the values X can take? What are the X is number of comparisons, no? So what are the values X can take? If it is in first position, X value is 1. If it is key is in second position, X value is 2. Key is in third position, X value is 3. And so on, key is in nth position, X value is n. If key is not at all present in the given list, what is the X value? If key is not at all present in the given list, what is X value?
N plus 1, sir.
No, even if key is not present also, we are not, what are the comparisons we are actually considering here? A of I not equal to key. That comparison only we are talking about, no? A of I not equal to key. That comparison we are talking about. How many?
Sorry, it will be N. It will be N.
Thank you. Okay. So let X be the number of comparisons. Okay, let X denote number of comparisons. Definitely it is going to be, it is a random variable. And what are the values it takes? 1, 2, and so on, N. So these are distinct values. So definitely this X is a discrete random variable. Now, but X, unlike the previous case where search is always successful, here we have two possibilities. Okay, no? whenever we search for a key, there are two possibilities. Search is successful, or search is unsuccessful. So these two things can happen. If search is successful happens, whether search is unsuccessful happens. If search is successful, whether search will be unsuccessful same time? No. If search is unsuccessful, whether search is successful is true? No. That means out of these two, only one thing will happen. Either search is successful is true. If it is not true, search is unsuccessful is true. If it is true, this is false. If it is false, this is true. That means what type of events are they? They are mutually exclusive. No? If one happens, the other one doesn't happen. No? If one happens, successful is true, unsuccessful is false. If unsuccessful is true, successful is false. Successful is false. Are there any other cases other than successful and unsuccessful case? No. Now, if success probability is P, what is unsuccessful probability or failure probability? If success probability is P, what is unsuccessful or failure probability?
1 minus P.
What is unsuccessful or failure probability?
1 minus P.
1 minus P. 1 minus P. 1 minus P. Now, in successful case, what are the values our variable takes? In successful case, what are the values our variable takes? Successful case, what are the values our variable takes? It may take value 1, 2, 3, 4, and so on, n. Now tell me, what is the probability with which it takes value 1? What is the probability with which it takes value 1?
1 by n.
That is when all positions are equally likely. But here we know that success probability is only P. In that case, it becomes a P by n, no? P by n. What is the probability that number of comparisons is 2? It is also P by n. What is the probability that number of comparisons is 3? It is also P by n. What is the probability that it is 4? It is P by n. It is also P by n. That is successful case. But what in unsuccessful case also we have no? Unsuccessful case, what are the values this variable can take? What are the values? It takes only value n. What is the corresponding probability? What is the corresponding probability? What is the corresponding probability?
1 minus P.
1 minus P. Now this random variable, it is combination of two mutually exclusive events, no? Okay, now the corresponding, this I call it as XS, successful case. This is XU, unsuccessful case. Okay, now actual random variable X, it is a sum of XS and XU, no? These two are mutually exclusive. Then expectation of X, we know that if they are mutually exclusive, expectation of X plus Y, it is same as expectation of X plus expectation of Y. What is X here? X can be successful case. Y means I can take it as unsuccessful case. So then it will be expectation of successful, unsuccessful. Now what is successful? This I call it as now XS. What is successful expectation? 1 into, what is expectation of XS? What is expectation of XS? 1 into P by N plus 1, 2 into P by N plus value and the corresponding probability weighted, no, product sum. And this one n into P by N. Is that correct? In unsuccessful case, what is expected corresponding expected value? What is expected value? This is unsuccessful case, no, XU. What is the expectation of XU? What is expectation of XU? Value and corresponding probability. N into 1 minus P.
N.
Now, therefore, what is X? X is nothing but XS plus XU. Now, what is expectation of X? Which is same as X. What is expectation? Therefore, expectation of X is expectation of x is expectation of xs plus unsuccessful case, successful case, unsuccessful case. What is this value? 1 into p by n plus 2 into p by n plus 3 into p by n and so on plus n into p by n plus unsuccessful such. What is the corresponding value? N into 1 minus p. N into 1 minus p. Now, if we simplify, what is that? This first part, p by n, we can take common now. And 1 plus 2 plus and so on, 3 plus and so on, n we get. And the second part, n into 1 minus p. Is that okay? This is expectation of x. Is that correct? What is this summation value? What is summation value? N into n plus 1 by 2 plus n into 1 minus p plus n into 1 minus p. Now n gets cancelled. So what is final value? P into n plus 1 by 2 plus n into 1 minus p. This is expectation of x. Expected number of comparisons in linear search with success probability p. With successful probability p. Now, what are we calculated? No,
Sir,
assuming that x p equal to 1. If p equal to 1, what is this value? If p equal to 1, what is this value? If p equal to 1, what is expectation of x value?
N plus 1 by 2.
N plus 1 by 2. That's what we derived yesterday, no? P equal to 1 means what? Such is successful, no? With this assumption, we showed that it is n plus 1 by 2, no? Is that correct? Okay. If expectation of x is, what is the value? If success probability is 0, that means such is always unsuccessful. How many comparisons we make? How many comparisons we make if such is always unsuccessful?
N.
N comparison.
So because p is 0 means this part becomes 0, n into 1 minus 0, so it is n. Is that clear? Is that clear? Is that clear? So this is.
Sir, one question, sir. Sorry to interrupt.
Please tell me.
Yeah, expected value of x, you know, sir, it is n into 1 minus p. I have understood about expected value of xs, but xu I am not clear, sir. I did not get.
Xu, it has only one value. Unsuccessful case, only one value occurs. No, it has no multiple values, only one value. Unsuccessful case, number of comparisons is n, no, brother.
Okay.
All unsuccessful cases, expected number of comparisons is only n, no.
Okay.
Are you getting? Are you getting?
No, sir. N into 1 minus p.
Okay, brother. This is array 1, 2, 3, 4. N is 4. Unsuccessful means here only unsuccessful occurs, no? In that case, how many comparisons we are making? We compare with this not equal, not equal, not equal, not equal. Then we say that it is unsuccessful, no? That means here also unsuccessful search, we are n comparisons only we are making, no?
Yes, sir. Yes. Yeah, n comparisons, yeah, we do in the case of unsuccessful, but expected value xu, e of xu is equal to n into 1 minus p.
If probability of success is p, then what is probability of failure?
1 minus p.
That this is corresponding probability, no? The probability with which it takes value n.
Okay.
Unsuccessful.
Yeah. Okay. Okay, sir. I am clear. Yes. Thank you, sir.
So this is expected running time of linear search. See, simple linear search algorithm itself, we need to make many assumptions, not in order to calculate average case or expected running time. So hence, no, most of the algorithms, this calculation is not done. Okay, no, not done. Only they do best case running time analysis as well as worst case running time analysis. And the best case is useless case. That is also called as, simply in loosely speaking, bogus case. It doesn't give any information about actual running time of algorithm. Out of many inputs, there may be one input or two inputs for which it is taking very less time. But all other inputs, practically, it doesn't take that much time. No, it is actually more, no, very much high. That's why best case is called useless case. Okay. Worst, that's why most of the time only worst case running time is calculated for algorithms. Okay. Now, next. Okay, this anyhow the same thing there only completed. Now let me. So I have given different statements here. You should tell me whether these are true or false. Okay. If the key is always present in position 2, we are looking for applying linear search algorithm, and always the key is present in second position. Always key is present in second position. Now how many times that comparison operation is performed in this case?
2 times.
2 times. 2 times. So that means if irrespective of value of n, t of n is 2. 2 can be written as 2 into 1. This is 2 into n power 0. What is its order of growth? What is its order of growth? What is its order of growth?
It is constant.
N power 0. N power 0. That is constant. N power 0. That is 1. Is that okay? Now, if we know that key is always present in second position, is it same as its running time is same as best case running time or not? If we know that key is always present in second position, running time of linear search, is it same as best case running time?
No, sir.
Yes, sir. Yes, sir.
Correct, now, brother. In the best case also, what is it is present in first position.
First position.
In the best case, first position, t of n equal to 1. And what is order of growth? N power 0. Here also it is order of growth is n power 0. Asymptotically, both are same. No, this is also same as best case. No.
Yeah. Asymptotically, yes, same. Yes.
I am not talking about whatever analysis we are doing. Everything is asymptotic analysis only. Okay. Exact number of comparisons is different. I agree, but asymptotically, both have the same order of growth or not. If key is present in second position, what is its order of growth? Number of comparisons performed is 2, and its order of growth is n power 0, which is same as constant. Is that correct? Is that correct? Hence, its running time is same as best case running time or not? In this case, its running time is same as best case running time or not?
Yes, sir, it is.
Yes. Now, instead of that, if I know that key is always present in position 100, assume that number of elements in the array is more than 100. Key is always present in position 100. Then what is T of n? 100. What is its order of growth? What is its order of growth?
N to the power of 0.
What is its order of growth? What is its order of growth? T of 100. What is its order of growth? 100 can be written as 100 into 1, 100 into n power 0.
N power 0.
It is also n power 0. That means whether
Yes,
this statement is true or not.
Yes, sir.
It is true. That means even if I know that key is always present in 100th position, its running time, is it same as best case running time or not?
Yes, sir.
Its running time, is it same as best case running time or not? If we know that key is always present in position 100, its running time, is it same as best case running time?
Yes, sir. So if you know the position of the key, it could be in any place. Then in that case, order of growth will be n raised to 0, no, sir? Even if in the other cases also 4, 5.
That is, so if I know that key is always present in 10,000 position, What is its running time? T of n will be 10,000. Again, its order of growth is n power 0. If it is 1 crore position, number of elements is more than 1 crore, say array given, we are given more than 100 elements, more than 1 crore elements, and we know that key is always present in 1 crore position. Then order of growth is it same as best case? Is it same as
Yes,
best
sir.
case?
Yes, sir.
Yes. So
Because
this,
sir,
this statement is also true. Okay. Now, if we know that key is always present in some constant position, either it may be 5 or 10 or 20 or 100, 1 crore, 10 crores, 100 crores, whatever it may be. If it is present in some constant position, that means what is its order of growth? What is
One,
its
sir.
order of
N
growth?
power 0. N power 0.
N power 0, that is constant. And that means it, what does it mean? It is a constant. No. That means what? It is independent of input size. No. It is independent of, here also it is in all these cases, a T of n value, it is independent of, in all these cases, T of n is independent of n or not. T of n is independent of n or not. In all these cases, T of n is independent of n or not.
Yes, sir. It is independent.
So when our algorithm's running time or number of operations performed in an algorithm, if it is independent of input size, then we say that that is constant time algorithm. That means its order of growth is whenever number of operations performed in an algorithm, it is independent of input size, then we say that it is a constant time algorithm. In that case, what is its order of growth? What is order of growth in this case?
N power 0.
N power 0, which is nothing but constant. Is that clear? So that means not only key is present in first position, even if you know that key is always present in second position, that is also same as best case. Even if I know that key is always present in third position, that is also same as best case. Asymptotically, it is same, no? Is the point clear? Is the point clear?
Yes, sir.
Oh, okay. So finally, that's what we are emphasizing. If
So
the
it
number
relates
of
to
please,
it relates to one algorithm hashing, no sir, hashing. There also we will be knowing exact position where that key will be available. So there also it will be, it is similar to that, it looks like to me.
if we know that key is always present in some specific position, then whatever be the number of elements in the input, no, it doesn't matter to us, no. See, if I know that key is present in fifth position, whether number of elements is 100 or 1000 or 1 crore or 1 lakh or whatever it may be, we are going to perform only 5 operations. No, then we say that it is constant. It is independent of input size. Is that okay?
Yes, sir. Yes.
Okay. Okay. So best case means not only first position, even if we are told it is in second position always, that is also best case only asymptotically. Exact number of comparisons is different. There one, here it is 2, but asymptotically it is same as best case running time. No, same as best case running time. Now, yesterday's class. So what? Someone has asked, sir, instead of taking, why are you taking this operation as basic operation? Why shouldn't we take this operation, I less than or equal to n, as basic operation? I less than or equal to n as basic operation. Now say we are considering this operation as basic operation. Okay. Same algorithm, basic operation we are changing. I less than or equal to n. It is also comparison, no? Here our basic operation is not this, a of I not equal to I less than or equal to n is our basic operation. So this is also comparison, that's why but this comparison is I less than or equal to n. This is the comparison. Now, in this case, input size is as usual, it is n. Input size is as usual, it is n. Basic operation is comparison. Now, what is next step? Let T of n be the number of times I less than or equal to n operation is performed when n is input size. Now, you tell me whether T of n value, it depends only on n and the actual values in the input also. T of n value, it depends only on n, but actual values in the input also. T of n is number of times I less than or equal to n operation is performed. That is, comparison is operation is performed when n is input size. That means when the array contains n elements. Now, in this case, T of n value, it only depends on n, or it also depends on actual values in the input. That is input instance.
Actual value also, sir.
Actual value also, no? So these are the examples. Now, for example, in all cases, n equal 4, all three cases, no, n equal 4, but T of n value, it is different, no? In first case, T of n is 1, correct, no? If 20, how many times this operation is performed? First, we will check 1 less than or equal to n, correct? Next, a of 1 equal to 20, over, no? Over. So only one time it is performed. Next, 50, 30, 15, 20, 15, 25, key equal 25. How many times this operation is performed? How many times this operation is performed? I less than or equal to n. How many times it is performed? First, we will check. In this case, I equal to 1, I equal to 1. While loop, we check 1 less than or equal to n. 1 less than or equal to 4. Correct. Next, I becomes 2. But here, a of 1 not equal to key, no. A of 1 not equal to key. So we go next condition, I becomes 2. 2 less than or equal to 4. A of 2 not equal to key. What is A of 1? The key is 25. A of 1 is 50. Here it is 30, 25. Not same. Next, I becomes 3. 3 is less than or equal to 4. So what's the condition it checks? A of 3 not equal to key. What is A of 3? 15 not equal to 25. Here also it fails. Next, I becomes 4. 4 less than or equal to 4. What is A of 4? 25. 25 not equal to 25. This fails. That means what? It says that key is found in 4th position. We stop. That means how many times this operation is performed? How many times this operation is performed?
4 times. 4
4
times.
times, no? But now let us consider instance 3. Instance 3. Instance 3. So we are looking for, say, key 86. Key 86 here. First, what happened? Okay, directly you can tell me, no? How many times this I less than or equal to n operation is performed? First, I equal to 1. Then what happens? 50 is not equal to 86. So I becomes 2. Next to 80 is not equal to 86. Next, I becomes 3. Okay, that condition is checked. 1 less than or equal to 4, 2 less than or equal to 4, 3 less than or equal to 4. Next, I becomes 4. 4 less than or equal to 4, true. Here 100 is not equal to 86. Next, I becomes 5. 5 less than or equal to 4. This condition is checked, but condition fails. Correct, no? Now, how many times that condition is checked? That operation is performed. I less than or equal to n operation is performed. How many times I less than or equal to n operation is performed in this case?
5 times, sir.
5 times. 5 times. In general, okay. Now, whether we have different cases here, best case, worst case, average case, or only one case. For different instances of same input size, we have different values. No, that means what? There are different cases. Now you tell me, what is best case running time? What is best case? What is the value? T of n? T of n? It is same as key is present in first position. That time it is performed only one time, no? Key is present in first position. Position 1. Is that okay? So that means it is same as what is order of growth? Order of growth is n power 0. That means what? Whatever we discussed earlier. So therefore T of n can be represented as theta of 1 or big O of 1, big omega of 1. All are correct now. So similarly, what is worst case running time? What is worst case running time? What is T of n? What is T of n? What is T of n in the worst case? In the worst case, what is T of n?
Order of n.
What is T of n value? When does worst case occur? When does
When
worst
the
case
element is
occur?
not
When
present
we
in the
consider
list.
I less than or equal to n as comparison, when does worst case occur?
In the case of successful search.
Unsuccessful search.
Oh, sorry.
In case of
N
unsuccessful,
equal to
that
5.
means key is not present at all.
Yeah,
In that
5.
case, how many comparisons are performed? How many times I less than or equal to n operation is performed?
5 times.
No, in general.
N plus
N
1.
plus 1.
N plus 1. Now, what is the difference? When we took this A of I not equal to key as our basic operation, we got here T of n equal to n only, no? T of n equal to n. But here, because this operation, we got n plus 1. But is there any change in the order of growth? What is its order of growth? N only. Again, this can be represented as again T of n is big O of n or big omega of n or theta of n. All are correct now. That means whether we take this first operation or second operation, there is no change in the asymptotic running time of this algorithm. Okay, but this operation is preferred. Why? Because this is the actual operation, no, where we are comparing one key with actual key with array elements. This is our work, no, main work, no. This is our main work. Okay, it does not mean that we should not take I less than or equal to n. Anything we take, same answers we get. Same answers we get. Okay, so that is about linear search, different cases. So if we know that the same algorithm key is present in n minus 10th position. Key is present in n minus 10th position. Then what is the running time in this case? Key is present in n minus 10th position. How many times comparison operation is performed? How many times comparison operation is performed?
N minus 10 times.
That means is it same as best case or worst case?
Worst case.
What it is worst case. If I know that key is always present in n minus 5 position, it is also same as this algorithm performs n minus 5 comparisons, no? So it is same as worst case only. It is same as worst case input only. It is same as worst case input only. Even if I know that it is key is present in n minus 100th position, is it worst case input or not? Is it worst case input or not? Is it worst case input or not?
Yes, sir.
See, however, I ask a question, you should simply count how many times this operation is performed. How many times this, if this same algorithm we are not changing, if key is in n minus 100th position, how many times this operation is performed? Simply you count that, that's all. How many times it is performed? How many times that A of I not equal key operation is performed? N minus 100 times only, no? What is its order of growth? n minus 100.
Yeah.
That means it is order of growth is n. It is same as worst case. It is same as worst case. Is that okay? Is there any confusion?
Sir, one confusion I have is, suppose if you know a key is always present in kth position, order of growth is 1. That is
Hmm.
best case.
Hmm.
So here also, if key is always present in, suppose n minus 10th position, always if key is present in always n minus 10th position.
N minus 10th position. So that's why no.
If it is,
This
if it is
this
always
algorithm
present,
is this. You should not change algorithm. Sir, instead of writing algorithm, I will start with n and compare backwards. Are you getting, brother? I think your doubt could is it the same?
yes, sir. If in the previous slide, no, sir, in the previous one, just what I understood was from the previous one, if key is present always in kth position, order of growth is n raised to 0.
Correct. But
So
k is a
similarly-
constant. That is important here. K is a constant. It should not be in terms of n.
Okay.
N minus 100 is not constant, no?
Okay.
It depends on n value, no, sir.
It depends on n value. So it doesn't work, no, that way. Or to be more specific, if there is a confusion, independent of n. Independent of n. Is that okay? K
Okay.
is a constant independent of n. Is that okay?
Yes,
Sir,
sir.
here can we always say independent of n, sir? But what if the n value is less than k?
Sorry, I could not. Could you please repeat?
Sir, here we are saying it is independent of n. K value is independent of n, right?
Yes.
Is the assumption that I mean
It is independent. It's not function of n. K equal to n minus 100 means then you should not consider it as constant. No, is it constant? No.
No, it's not constant.
Not function of input size. Not function of input size. That is the meaning, no?
In this case, position always varies according to the size of.
Okay. That is definitely that varies, but still number of comparisons we perform is same n minus 100 only, no, always. Whatever be the value of n. See, running time we are not doing for one specific instance. It is for any instant whose size is input size is n. Okay, I think you have some doubt. Okay, let me ask you some question. Linear search, always n value is n value. You are always given an array which contains 1 lakh elements. 1 lakh elements. Now you tell me what is the time this algorithm takes to search for an element? Always I know that it has only 1 lakh elements. Array contains 1 lakh elements. What is the time it takes to search for an element here? N value is always 1 lakh only. N value, it is not a parameter. It is fixed, always 1 lakh. Input size is always 1 lakh. What is the time it takes to search for an element?
Constant time?
It is constant. Thank you very much, ma'am. Okay, now it is constant because whatever analysis we do, n is a variable. The moment we say n is a constant, always we have 1 lakh elements, 1 to 1 lakh. 1 lakh. The amount of work we are doing is maximum how much 1 lakh number of comparisons we perform, no? Maximum 1 lakh comparisons. That 1 lakh can be written as into n. It's a constant, no? Order of growth is n power 0 over. So what is the time it takes? What is time it takes? Constant time, no? Is there any, do you have any doubts here?
No, sir.
No, sir.
Oh, okay, thank you. Okay. Okay, now one simple algorithm we take and we count how many times a particular operation is performed in this algorithm. Okay, now this is some dummy algorithm. Okay, now our main intention here is to count how many times a particular step in the in this algorithm is repeated. Now you tell me how many times this product equal to product into I. This operation is performed. How many times product equal to product into I operation is performed?
Ten times.
That means how many times this sum equal to 0 operation is performed? How many times sum equal 0 operation is performed? One time
Only
only in
once.
this entire algorithm. How many times product equal to 1 operation is performed? How many times product equal to 1 operation is
One
performed?
time.
One time.
Only one time. Now, how many times product equal to product into I operation is performed?
10 times.
When I equal to 1, it is performed one time. When I equal to 2, one time. And this one, when I equals to
10.
10 also one time. So that means what? This
10
operation
times.
is performed for each value of I, 1 to n, one time. So what is this value? We know that upper bound minus lower bound plus 1, n minus 1 plus 1, it is n. Is that okay? Okay. Now tell me, how many times this sum equal to sum plus j operation is performed?
10 times.
N square times.
N square.
How many times sum equal sum plus j operation is performed?
N
See,
times for each value of I.
okay. When I, for each value of j, j equal to 1, one time it is performed. J equal to 2 also one time. And this one, j equal to n also it is performed. That means for each value of j 1 to n, one time it is performed. It is total how many times? It is n times. Okay, it is performed n times. But this entire work is done for, this entire thing
Another
happens
10
for
times.
each value of, when I equal to 1, we repeat this. When I equal to 2 also, we repeat this. When I equal to 3 also, we repeat this. Is that correct? Is that
Yes.
correct?
Yes,
Is that
sir.
correct?
Yes, sir.
See, when I equal to 1, j varies from 1 to n. Similarly, when I equal to 2, j varies from 2 to n. Similarly, when I equal to n, j varies from 1 to n. Is that correct? That means how many times this operation is performed? How
N
many
square.
times this operation is performed? For each value of j, 1
each
to n,
value of
one time it is performed. But this entire operation is for, this entire thing is performed for each value of I, 1 to n. What is this value? This value we know that it is n. So this already we discussed, no, this type of examples. This becomes n into n. So it is n square. Is that correct? Is that correct?
Yes, sir.
Okay, so this operation is performed n square times. This operation is performed n times. This operation is performed n times. So what is total running time of this algorithm? We can simply write it as theta of n square. Is this correct? Is this correct? What is running time of algorithm is theta of n square. Why? Because this operation is performed one time. This is performed. This step is performed how many times? N times. N or n plus 1. Last count, if you count, no, it will be n plus 1. Otherwise, it will be n. This also will be performed n times. This will be performed. This will be performed n squared times. This operation is also performed n squared times. This is performed one time. If you add up all these things, what is the highest order term? What is the highest order term? What is the highest order term?
N square.
n square. So that means its order of growth is
N square.
order of growth is n square. So T of n can be written as theta of n square. If we write big O of n square, this is also correct. If we write big omega of n square, this is also correct. Okay. Even if I write T of n is big O of n square log n, is this correct or not? T of n is big O of n square log n. Is that correct or not?
Yes, sir.
That is also correct. See, once you know order of growth, infinite number of ways you can represent its running time. Correct, no? Once you know what is order of growth of that, its running time, we can represent it in infinite number of ways. Correct, no? Is the statement clear? We can represent its running time in infinite number of ways. I can also represent it as T big O of n factorial. Is that wrong? Is that wrong? Is
sir.
this correct or not?
Correct only.
You know that this side it is n squared. Now you forget about all this. After that, it is only definition of big O, no? It is correct. But nobody represents like this. It does not mean that it is wrong. Always big O gives upper bound. Upper bound should be as small as possible. So that's why this is our better answer in terms of big O. Okay. Now you tell me how many times sum equals sum plus j operation is performed. Which
N
operation
square.
is performed more
N
number of
square.
times in this algorithm? Which
Sum
operation is performed more number of times in this algorithm?
Sum.
Sum equals sum operation, sum plus j. That is addition operation is performed, no? How many times that operation is performed? How many times that operation is performed?
N
Each
square.
value of I n minus I times.
That means anyhow this all those things I am not writing. All this we know. No, this is one time. This is one time. This is n times. This is n times. Now this one. It is when I equal to 1, I equal to 2, I can go up to n. When I equal to 1, what are the values j takes? In this case, when I equal to 1, what are the values j takes? J varies from 1 to 1, 1 next to 2, 3, and so on. It can go up to n. When I equal to 2, what are the values j takes? When I equal to 2, what are the values j takes? J equal to I know.
2, sir.
2 to
3 and 1. 2, 3.
2, 3, and so on. Last n. When I equal to
1 time.
n minus, when I equal to n minus 1, what are the values j takes?
N minus 1 and
N. When I equal to n, what are the values j takes?
n time. 1
Yeah.
time.
1 time.
1 time. So total how many times this is performed? When I
N
equal to
into
1,
n
how many
minus 1
times
by 2.
this sum equal sum plus j operation is performed? J equal to 1 time, 2 1 time, like this. How many times it is performed? n
N.
times. Is that okay? When j
Yes, sir.
when
N
I
minus
equal
1
to
time.
2, how many times it is performed?
N minus
N
1
minus
time.
1.
This is sigma j equal to 2 to n 1 time. What is this value? Please remember this sigma I equal to lower bound to upper bound, low to high. 1 is high minus low plus 1. Correct, no? So what is this value? N minus
1.
2 plus 1, n minus 1. So this is performed n minus 1 times. And this one, how many times it is performed? 2 times. It is 1 time. Then what is the total number of times? What is total number of times? What is total number of times?
n into n plus 1 by 2, sir.
So it is when I equal to 1 n times, I equal to 2 n minus 1 times, I equal to 3 n minus 2 times, and so on when I equal to n 1 time. So what is the total number of times? Sum of first n natural numbers, it is n into n plus 1 by 2 times. Is that correct? Let T of n be the total number. And this is the operation which is repeated more number of times now. So T of n, we can write it like this. Is that correct? Is that correct or not? Is that correct or not? I am only counting this. I am only counting this. Is that correct? What is its order of growth?
N square.
N square. Now T of n can be written as big O of n square, theta of m square, whatever we want. But okay, we need not do this entire thing no every time. Once we know this, directly it is visible here no. So this operation, it is performed for each value of j I to n no. J equal to I one time, j equal to I plus one time, j equal to I to n, for each value one time it is performed no. And this entire thing is performed for each value of I from 1 to n, 1 to n. Then how to simplify this? What is this value? What is this value? What is this value?
N.
Please remember this. Okay, no. What is that value? N minus I plus 1. Is that correct? Is that correct?
Yes, sir.
Okay. Now when this one, there are different ways of simplifying this. One simple way is I equal to 1. If I substitute, what is the value I get here? N minus 1 plus 1. I equal to 2. N minus 2 plus 1. Plus, and I equal to 3. N minus 3 plus 1. And so on. When I equal to n, n minus n plus 1, which is nothing but, it is same as n plus n minus 1 plus and so on plus 1. Again, it is like this, no? That is one way of simplifying. The other way is the same quantity, we can simplify like this. What is that we have? Say T of n is sigma I equals to 1 to n minus I plus 1. Is that okay? Now, this we can separate, no? We can separate. So this can be written as sigma I equal to 1 to n minus sigma I equal to 1 to n I plus sigma I equal to 1 to n 1. Is that okay? Is that okay? Is that correct or not? Is that correct or not? Now tell me, what is this value? Sigma equal to 1 to n 1. What is that value?
N.
What is this value?
N, sir.
N. So what is value of sigma I equal to 1 to n I? What is this value?
N into I, sir.
Plus 1 by 2.
No. Sigma I
N
equal to
minus
1 to n I.
N minus 1 plus I.
No. Sigma I equal to 1 to n I. When I equal to 1, this value is 1. When I equal to 2, this is 2. When I equal to 3, this is 3. And so on, when I equal to n, this is n, which is same as first
N.
natural number sum, no? Is that correct? Sigma I equal to 1 to n I. It is same as n into n plus 1 by 2 or not?
Yes, sir.
Okay. So this place we can write it as n into n plus 1 by 2. Now what is sigma I equal to 1 to n? What is sigma I equals to 1 to n? N is independent of I. No, we can take it outside. This can be written as I equal to 1 to n 1. What is this value? What is this value?
N.
N. So finally this entire thing is
N square.
n square. So first part we will get n square. So therefore, what is T of n? What is T of n? What is T of n? So let us write it here. So T of n is n square minus n square by 2 minus n by 2. Okay, no? Plus n. Is that correct? which is same as n square minus n square by 2 minus n by 2 plus n. Okay. What is this value? Okay, this anyhow you can simplify. N square by 2 minus n square minus n square by 2, it will be n square by 2. Minus n by 2 plus n, it will be n by 2. This we can write it as n if I take common, n by 2 if I take common, n plus 1 we can write, which is nothing but n into n plus 1 by 2. That's what we got now. Is that clear? So when this is not straightforward, we actually split like this and simplify. Okay. But in this case, it is easy. But actually, we'll get some lengthy expression. No, that time we split it and each value we calculate, then simplify that. Now, you please tell me what is the answer we get here? What is number of times this operation is performed? That I call it as T of n. What is T of n then? Directly, you please tell me what is T of n?
N square.
No, direct we need to j equal to I plus 1 to n, one time it is performed. This entire value is performed for each value of I from 1 to n. Now you tell me what is this value?
N.
N minus I, sir.
N minus I. I equal to, this is upper bound. Upper bound is n minus lower bound I plus 1 plus 1. N minus upper bound minus lower bound plus 1. What is this value?
N minus I.
N minus I. This can be written as one way of writing n minus sigma equal to 1 to n I. What is this value? We know this now. Just now we calculated. This is n squared. We also know this. What is this value? N into n plus 1 by 2. Now sum of first and natural numbers term. So this is nothing but n square minus n into n plus 1 by 2. What is its order of growth? What is its order of growth? What is order of growth?
N square.
N square. Then after that, however we want, we can represent. All are correct now? Or from this point onwards, directly also we can simplify. How? I equal to 1 you substitute. What is the value you get? N minus 1. I equal to 2 if I substitute. Next I equal to 2 I need to substitute. N minus 2 I'll get. Next I equal to 3 if I substitute. N minus 3. What is the last value that we need to substitute? N. Then it will be n minus n. Now you tell me what is this value? What is this value? N minus 1 plus n minus 2 plus n minus 3 plus n is 1. It will go up to 0, 0, which is nothing but, if I write the other side, 1 plus 2 plus n is 1 up to n minus 1. What is this value? What is this value?
n minus 1 into n by 2.
N minus 1, n minus 1 into n minus 1 plus 1 by 2. That is n into n minus 1 by 2. Correct now? Is that okay? Okay. In this case, this one, please tell me expression. What is T of n? Let T of n be the number of times this operation is performed. What is T of n in this case? Sigma I equal to 1 to n, sigma j equals 1 to n minus I. 1 to n minus I, no? 1. What is this value? What is this value?
N minus I plus 1.
Upper bound is n minus I. Lower bound is
Minus
1
minus
plus
1.
1.
Yes, sir.
Upper bound, this is n minus I. Lower bound is 1 plus 1. Upper bound minus lower bound plus 1. This is also same as n minus I. What is this value? Just now we calculated, no? What is this value? N into n minus 1 by 2. What is its order of growth?
N square.
N square. Once you know order of growth, we can play with asymptotic notations.
Yes, sir.
Now you please tell me, okay, in this case, how many times this operation is performed?
Total n square by 2.
How many times, sir?
It's n square by 2. Total. Yeah.
N square by. So here, unlike previous examples, here I is I plus 2. First I equal to 1 means what is the next value of I? 3, no? Next value of I? 5. For odd numbers only it is doing, no? Is that correct? Is that correct?
Yes, yes.
For example, okay, yeah, n equal to 7. How many times this operation is performed? How many times this loop is
4 times.
repeated? When n
Four.
equals 7, how many times loop is repeated?
4 times.
4 times. 4 times. When n equal to 8,
4 times. 4 times.
oh sorry,
So outer loop iterate n by 2 times. The inner loop iterate n times for each value of I.
I am just trying to close this top part. Automatically goes. Okay. I equal to n, I equal to n. So n equal to 8, how many times? 4 times.
Four.
Now, similarly, if I take n equal to 6, how many times?
3 times.
3. N equal to 5,
3 times.
3. Now can we generalize? N equal to 5 and 6, answer is same. N equal to 7 and 8, answer is same. Can we generalize this now?
Yes, n by 2 times.
Exactly. We can write it as ceiling of n by 2 times. Is that correct? What is ceiling of 6 by 2? Ceil of 6 by 2, it is ceil of 3. What is ceil of 3?
3
What is ceil of 5 by 2?
2.
is 3.
2.5. That means next integer which is greater than this given number, number 2.5, no? Smallest integer which is greater than 2.5. That is the 3 only, no? So this is repeated how many times? Ceiling of n by 2 times. Is that okay? Is that okay? Now, how many times this operation is performed? How many times this operation is performed? For each value of j, 1 to n, 1
N
time
times.
means it is n times. This
Yes, sir.
operation is performed n times. This loop,
1
but
by 2.
this loop, no, for each value of I, it is repeated. This third loop, outer loop is repeated n by 2 times. Now you tell me total how many times this loop is repeated? How many
Sigma
times this loop
1
is
to n
repeated?
by 2.
Outer loop n by 2. This is n. So total n by 2 ceiling of n by 2 into n times it is repeated, no?
Yes, sir.
T of n. But in asymptotic analysis, no. Ceiling, floor, they do not have any impact, no? Smaller order times itself, no impact.
Yes, sir.
And where is the question of this ceiling, floor? Okay, only one value more or less. Okay. What is order of growth? Here also n square.
N square.
Is that okay? Now in this case,
The order of growth is n log n.
yeah. Yes, sir, correct. So others, is it clear? How many times this loop is repeated? Approximately, you tell me. How many times that outer third loop, outer for loop is repeated?
N by 3 times.
Is that clear why it is n by 3? If n equal to 1, how many times it is repeated? If n equal to 1, how many times it is repeated? Outer loop?
1 time.
Outer loop we are talking about. 1 time. N equal to 2?
1 time.
N equal to 3? 1 time. Now, n equal to 4? 2 times, no? I equal to 1, next I becomes 4, 4 less than or equal 4, correct? So 2 times it is repeated. 5 also 2 times, 6 also 2 times, n equals 7, 3 times, 8 3 times, 9 3 times. Now we should be able to generalize, no? 1, 2, 3, same answer. 4, 5, 6, same answer. Now can we generalize this similar to previous example? In general, we can we write it as ceiling of n by 3? Ceiling of n by 3? Is that correct?
Yes, sir.
Correct, no. So it is 1 by 3, that means 2 by 1 by 3, 0.3 something, okay, no, 3. Ceiling of this, it is 4. Similarly, this is 2 by 3. Oh, sorry, this is 1 now. 2 by 3. What is this? This is also 0 point something. This value is also 1. Okay. Okay, this is ceiling of 3. Now, how many times this loop is repeated? This is multiplication operation, j into 2.
Log n times.
So first j becomes 1. What is the next value of j? J is initially 1. What is the next value of j?
2.
1 into 2, that is 2. What is next value of j?
4.
2 into 2, that we can write it as 2 square. This 1 we can write it as 2 power 0. Okay. Next, what is next value of j? 2 square into 2.
8.
2 cube. And so on. Next, it becomes 2 power 4. Next, it becomes 2 power 5. 2 power 5. Is that okay? Now, for easier calculation, what is that? Let us assume that we are only interested in asymptotic. No, assume that n is of the form 2 power k, where k is greater than or equal 0. K is greater than or equal 0. 2 power k form. That means it is either 1, 2, 4, 8, 16, 32, 64, something like that. Like that. So then what happens? So first this will be 2 power 0, next it will become 2 power 1, next to 2 square, next to 2 cube, next to 2 power 4, next to 2 power 5, and this one next. Whenever it is 2 power k, it stops, no? Whenever it is 2 power k, it stops, no? Is that correct? Whenever it is 2 power k, it stops. Total, how many times this operation is performed? This loop is repeated, inner loop?
K times.
K plus 1 times, no, sir?
Yeah, K plus 1 times.
0 to k, no. 0 to k means how many times? 2 k plus 1 times k plus 1. Now, n equal to 2 power k. What is k? We know
Log
that
n
n
base
is
2.
equal to 2 power k. What is k by the definition of logarithm? K is log n base 2, no?
Yes.
K is log n base 2.
Yes,
Is
sir.
that okay? So k plus 1 means what? This is same as log n base 2 plus 1 outside,
Yes, sir.
plus 1 outside. Is that okay? So now
Yes, sir.
inner loop is repeated how many times? Okay,
10
better.
times.
Let us write it like this, no confusion. 1 plus log n base 2 times with assumption that n equal to 2 power k. 1 plus log n base 2 times. Outer loop is repeated how many times? Outer loop is repeated how many times? Ceiling of n by 3 times. Now what is it? This can be written as T of n is roughly this much, no? This can be written as ceiling of n by 3 in plus ceiling of n by 3 into log n base 2. What is its order of growth? What is its order of growth? What is its order of growth?
N log n.
It's n log n, no? This is smaller term, so we cancel this. Here there are no constant coefficients. So finally, this is only order of growth. No, what is this? 1 by 3 we can ignore here. 1 by constant we can ignore. So n log n is order of growth. No. Is it clear? Any doubt here?
No, sir.
Is there any doubt? So T of n can be written as then now big O of n log n. Why I am saying this no, simply by seeing 2 for loops, we should not say n square, 3 for loops, n cube. That doesn't work always, no. It depends on how are we actually incrementing values here. Okay, no, whatever I and j, whatever we use, depending on that, answer changes. Okay. Now you please tell me what's the answer in this case.
The order of growth is n log n in this case also.
This case also n log n is correct. Whether all of you have you understood why it's n log n? It is same as previous algorithm, ditto. Only thing there we are doing forward increment. Here it is backward decrement, starting with n, coming down. So okay, let us see. Here initially n, after that it becomes n minus 2. Next it becomes n minus 2 minus 2. Next it becomes n minus 2 minus 2 minus 2, and so on, and so on. Okay, the same thing we can write it as n minus 0. This I can write it as n minus 2, 2 into 1. This we can write it as n minus 2 into 2. This we can write it as n minus 2 into 3, and so on. It goes like this. It goes like this. Say when it becomes n minus 2 into n by 2. N minus 2 into n by 2. What is the value we get here? What is the value we get here? 0. That means condition fails or not? Condition fails or not? This is
Yes.
This we can write it as n minus 2 into 0, n minus 2 into 1, n minus 2 into 2, n minus 2 into 3, and so on, n minus 2 into n by 2. That time it fails. That means up to which condition it works? N minus 2 into n by 2 minus 1. No? So now you tell me how many times we repeated? 0, 1, 2, 3, n by 2 minus 1. The 0 to n by 2 minus 1 means total how many times? 0 to n by 2 minus 1 means total how many times?
N by 2 times.
N by 2 times. N by 2 times. So this loop is repeated n by 2 times. And what is the assumption here? Here
Sir,
we
can
are
you explain it
assuming
again,
as
sir?
n is even. Otherwise, exactly this, no, this n is even. So this is n by 2 times, n by 2 times. Now, how many times it is repeated? It is similar to previous one. First, it is n. Next, what is the value we get?
N by 2.
N by 2. Next,
N by 4.
n by 2 by 2. Next,
N by
n
4
by
by
2
2.
square by 2. N by 2 cube by 2.
Yes, sir.
This one, it goes like this, no? This we can write it as, this n, we can write it as n by 2 power 0. This
Log
we can write
n.
it as n by 2 power 1. This is n by 2 square. This is n by 2 cube. N by 2 power 4. And so on it goes. If I assume that n is of the form 2 power k is greater than or equal 0. N is 2 power k means automatically n is even, no? If n is of the form 2 power k, automatically it is n is even. So when does it stop? N by 2 power k. After that, no, it is not repeated. Up to this only it repeats. Total how many times? How many times?
3 times.
K
K
plus
K
1.
plus 1. What is k? Earlier we calculated, no, log n base 2. So it is 1 plus log n base 2. Top one is n by 2 times. This is 1 plus log n base 2 times. So total how many times this operation is performed? N by 2 into 1 plus log n base 2. So therefore, what is T of n? Order of growth of
N
T of
log
n?
n to the base 2.
N log n.
To the base 2.
Correct, no? Is there any confusion? Is there any doubt? So
Sir,
I
can
have
you
done only
explain third step,
two
sir?
levels, 2 for loops. Okay, no, 2 levels. It can be even more than 2 also. Okay, no, this combination we can. Okay, let us see some more.
Sir, I did not get k plus 1. Sir, can you please explain?
Ah.
K plus 1. I got k plus 1. No? How we got k plus 1?
Okay. So is this clear, brother? N by 2 power 0, n by 2 power 1, n by 2 square, n by 2 cube, n by 2 power k. Is that clear? 2 power k
Yes.
value is same as n, no? N by
Yes.
n means it is 1, it stops here. After that, is that clear up to this?
Yes. Yes.
So now you count how many terms are there? That is, this is 1 term, 2, 3, 4, 5. See, 0 to 0, 1. This is 2. It is in order only. No, number of terms easily we can count 0, 1, 2, 3, 4 up to k. Okay, that also if you want, I can say like L equal to 0 to k one time. Total k minus 0 plus 1, no, which is same as k plus 1. 0 to k we are counting. Total how many times we counted?
Okay, since we are including 0, it is okay.
That's all. Okay, that's why 0 to k, upper bound is k, lower bound is 0 plus 1. Upper bound minus lower bound plus 1, no formula. It is k plus 1.
Okay, sir. Thank you. Yeah.
This is also one iteration, no, brother? This is also one iteration, no?
Yes, sir. Yeah.
Okay. Okay, you please tell me, okay, answer for this. We have already discussed this type of things. You please tell me what's the answer in this case. Again, our goal is same thing.
Log n into log n.
Thank you, sir. Already this example we have already seen, no? How many times it is repeated? How many times if it is repeated? If I assume that n is of the form 2 power k,
Log n times.
1 plus log n base 2 times, no? Is that correct? It is repeated. Same, no? 1 plus log n base 2 times. How many times this is repeated?
1 plus log n is 2.
This is also 1 plus log n base 2 times, no?
Yes, sir.
Is that okay? Overall, how many times it is repeated? 1 plus
Log
log
n.
n base 2 into 1 plus log n base 2. What is its order of growth?
Log n whole square.
What is its order of growth? What is its order of
Log n base 2 whole square.
log n base 2 whole square, no? These are smaller terms, no? This is the order of growth is, so order of growth is log n whole square. Anyhow, order of growth, we don't require base, no? Log n whole square. So T of n is we go of log n whole square. Is that okay? Is that correct?
Yes, sir. Yeah.
Okay. What about this?
The same thing, log n whole square only.
Thank you, madam. Thank you. Okay, this also we discussed. No, it is only forward, backward. That's all. How many times this is repeated? Okay, approximately log n base 2 times. This also log n base 2. Overall, it is how many times this operation is repeated? Approximate value log n base 2 whole square. Its order of growth is same thing, log n square. Is that okay? Yeah, any doubt in this example?
No, sir.
Okay. Okay, now let us see this. How many times third step is repeated? Outer for loop.
Is it n square, sir?
Root n times.
Root n times.
N square is not correct, madam. The same line I square less than or equal to n.
Like root
Can
n
we
times.
replace it with
Sir, is it C log
same
root
line
n?
I less than or equal to root n? Is that correct?
Yes, sir.
Anyhow, I is positive, no? That's why. Okay.
Yes, sir.
If we replace that with I less than or equal to root n, then it is clear, no?
Yes, it is correct.
Okay. Okay, I stop it here. You please try this. Okay, now again 6:30 we'll discuss this example again. Okay. Thank you.